sitting in Anchorage right now, currently working for the state of Alaska. He came out here last summer and did some work for the Science Center. He's going to give us an overview of his work with drones in wildlife research and conservation, both here and in other areas. And let you go, Greg. Thank you.
Great. Thanks. You guys can hear me all right? I gather we did a little test before. And yeah, if you guys have any questions, feel free to raise your hand or speak up. Yeah, happy for this to just be a conversation, not just a lecture here. This title slide, assuming you guys can see it, should be actually kind of timely because this is from my work down in the Antarctic Peninsula. So this is the kind of setting that Marianne and Milo are heading into right now. There's spectacular mountains and glaciers and actually a surprising amount of green as you get into the Antarctic summer. As Kate mentioned, I had the joy of working out of Cordova, doing a little collaboration with Prince William Sound Science Center this summer. And my experience was a week of sunshine. I think of Cordova and I think of blue sky and a gentle breeze and sunshine. And everybody told me that's frequently not the case. And I believe that because I did live in Juneau for a little while this last year. But I want you guys to know that I have very fond memories of Cordova. And so it's a joy to be chatting with you guys. That was kind of a nice byproduct of my recent journey as a one-time federal scientist. Amid all the chaos, I started saying yes to some collaborations outside of my federal work, and that's part of what brought me over to Cordova. And it was totally, a great decision. So even though I'm now with the Department of Natural Resources in the state, this is part of my extracurricular life still, doing these collaborations. So even though, I'm a relatively recent transplant to Alaska. I just moved out to Juneau in September of last year, moved up to Anchorage this year for my state job. I've been working in Alaska since about 2010. These are some photos from my time as a technician for NOAA. I've been in and out of the federal government for a very long time. I was out in the Pribilof Islands for a number of summers doing fur seal research, a lot of tag resighting and population counts, monitoring. A lot of times just working along, you can see these blinds that were along the cliffs, monitoring the breeding population out on St. Paul Island. And then, you'll see on the bottom left, those are not fur seals. I was doing some brand resighting with stellar sea lions off of Kodiak for a little while. And that was kind of where I got involved in marine science for the first time. I'd done a bit of wildlife biology before, working with bats, did some stints with lizards here and there. But this was my first time working with marine predators, getting out to coastal Alaska, and I fell in love with all of it. So after a number of summers, I eventually got a grant to go to graduate school, and I was hoping to continue working with seals. And that's kind of what steered me very hard into drones. So I connected with my eventual PhD advisor, Dave Johnson, who sometimes works out here in Alaska, but he's done a whole bunch of work with near polar seals and whales, you can see in this photo. But we connected over our shared interest in seal research, and we got to talking, and it turned out we had a lot of compatibility as a student advisor combination, but he had just gotten a big research grant, or actually a big facilities grant from the National Science Foundation to build a drone lab, state-of-the-art lab for advancing drone techniques in this is Duke University in coastal North Carolina. So he said, basically, you'll have a lot of leeway in what you want to do in designing your own PhD, but it's going to have to do with drones. That's where all the lab's resources were. So that's kind of the genesis of this talk that I'm giving, is just me kind of trying to figure out, I'm a wildlife biologist. I've got to use drones. Where do drones fit into the toolkit of a wildlife biologist? How can I kind of advance the field with this technology that was pretty new to me at the time? So I've now been flying for about 8 years. So that's kind of a niche that I've carved out, but I'm still always trying to think about, where are the strengths, where are the weaknesses, what are the opportunities for us to use drones to kind of improve the way that we observe and understand wildlife populations. I like to start out with this just to kind of underscore, like, when we think about drones, you think about the beautiful aerial imagery that you get, but that's not inherently, revolutionary. People have been getting aerial imagery for a long time. This example is from about 1907. This German scientist strapped a camera with a timer onto pigeons, and that's a good aerial platform. I guess it's really appropriate that I'm giving this talk to the Audubon Society. Yeah, you got good images. Clearly, it never went mainstream, but getting that aerial perspective, they recognize the value from a long time ago. And I could say, growing up, my grandfather was always flying remote control airplanes, and he did something very similar, putting in a camera with a timer and getting photos of the farmland and the forests around his house. So, aerial imagery in itself has been around for a while, but there are a few key technological advancements that make drones something new that we can leverage. This is, I guess, what do we talk about when we talk about drones? What do we mean? It's not just a remote control hovercraft or a remote control plane. What makes a drone is all of the different technologies that we're able to put on an aircraft now. So a lot of these came around in the last 20, 25 years. A couple of key things like brushless motors let us spin a lot faster without the friction of a mechanical brushed motor. But really, a lot of the technologies that kind of brought drones into the mainstream come from your cell phone. Think about like these lightweight lithium batteries, very high density of power for a very small footprint in terms of weight and size. Think about like the tiny GPS that's in your phone, the accelerometers, the cameras, all these different sensors that, if you can fit them in your phone, you can put them onto a lightweight carbon fiber frame. And suddenly you've got more than just remote control aircraft. You've got an onboard computer that's interpreting all kinds of sensors. So if you think about like if you had a remote control hovercraft, a lot of times you're putting in your manual inputs into the joysticks on the controller. Those are telling motors, go faster, go slower. That's not how a drone works. You're sending those signals, similarly, you're pushing the levers or the sticks on your controller, but those are going to a receiver that's going into a computer on your drone. And that computer is taking in your input that's saying, go left, go right. But it's also saying, here's where I am in GPS space. Here's the wind that I'm getting. Here's the weight that I'm kind of balancing so that the drone's not descending. It's taking in all kinds of different information. And then when you put in, generally, if you tilt your stick to the left, it's saying move your target GPS point to the left, and then do all of those calculations, take in all your information to move the aircraft. So that's one of the reasons why it's a lot easier to fly a drone. The learning curve is a lot friendlier than these people. You can see these YouTube videos of these crazy pilots doing remote control stuff. They have extremely precise controls because they need that. With a drone, you can just kind of throw in some inputs and the computer does a lot of the hard work for you. Drones aren't always necessarily aerial or aircrafts. These are a couple, I guess you call them autonomous robots that we had, but we could call them drones as well. In my PhD lab, that group out in North Carolina, we had a rover, and it had a lot of the same. We had a GPS and an onboard computer and the radio telemetry receiver. So we would put in a bunch of GPS waypoints and with an infrared camera, and we had it patrolling the beaches looking for sea turtle nests in coastal North Carolina. And similarly, we had the same kind of sensors and communication devices hooked into this little mini, I guess it was kind of a model dinghy that we picked up. And the student was able to turn that into a water quality sampling device. Again, it was able to kind of read its position, balance all the different inputs from its sensors, the different directions it was getting pushed around by the current and the wind. And we were able to actually get into some really hard to reach places. If you think about like mud flats and the kind of oyster reefs we have in Eastern North Carolina, and get some samples that you wouldn't have been able to get from a typical research vessel with a deeper draft. But for the purposes of this talk, and probably 98% of the time you hear people talking about drones, I'll be talking about these aircrafts. So usually multi-rotor, so like this quadcopter here, or sometimes hexacopters, I've used those, or a fixed wing. I have a couple models of fixed wing that I've used. This one in the middle is kind of just flies like a plane. You have to throw it into the air. It comes in, needs kind of a runway to land. But increasingly, people are starting to use this this kind of orange type here. This it's called a vertical takeoff and landing VTOL, or transitional aircraft that'll hover up and then transition to kind of flying like a plane. And the main thing there is just when a plane is flying, it's a lot more efficient use of the battery. It's using lift to stay aloft instead of constantly running those motors like you would have with a multi-rotor craft. There are trade-offs there. You generally get more endurance with a fixed wing, but you have a lot more precise control, of course, when you have a multi-rotor and it's hovering in place. Yeah, depending on the task, sometimes you want to have a larger area covered, or sometimes, when I was working with the Science Center this last summer, we were launching and recovering from a boat, and even this VTOL aircraft, I wouldn't really trust landing that in a boat. So we were doing everything exclusively with a quadcopter. So this is just kind of the direction that I'm going to go today. And you can jump in, as I said, if you have any questions or if you want to hear more about something. I'm going to kind of go over what I see as some of the key strengths of using drones, specifically for wildlife. Some of the limitations, some of the things that have kind of made it difficult to work with drones in my experience. And then some of the ways that I think drones are opening up new opportunities for studying wildlife based on those qualities. And then I'll close out with just a little overview of the project that I was doing with the Science Center this summer. Tell you guys how it went and some of the lessons we've learned, and yeah, hopefully we'll be back at it next summer. I don't need to underscore this too much with folks in Alaska, but you're all aware that flying around in small planes can be dangerous, and it's especially dangerous for wildlife workers because I guess my understanding is that when you're in a small plane, the two things that increase your safety are flying high and flying fast. High, so you have time to recover if something goes wrong, and fast, so you've got that lift. You're not likely to stall or lose that lift and fall out of the sky. But when you're doing wildlife surveys, you're generally trying to fly low and slow. You're trying to move slowly so you have a chance to see or record the wildlife, take photographs without a lot of blur, with a lot of kind of continuous coverage. And you're flying low because you want to get that, high resolution as close as you can get safely to the animals. And so, this study that we frequently cite just found that I think 2/3 of deaths or career-related deaths for wildlife biologists were from plane crashes. And so do we just kind of underscore anytime you can avoid putting a person in the air for wildlife research, it's worth it. So that's, safety is just kind of the no-brainer for a lot of drone work. Affordability, you guys are aware, owning a drone is a lot easier than owning an aircraft. And then this was just a little workup that I did when I was working with the Park Service down in Juneau. We were transitioning our program from using occupied aircraft surveys, so having the pilot and a couple biologists in usually a small plane with a belly mounted camera. We were moving over towards using drones for our seal surveys. I could talk a little bit more later about why that makes sense for seals and not for other species. But you can see the startup cost, it's fairly pricey to get drone systems, and I always recommend having redundancy because things go wrong. I've lost drones in Antarctica. There's one down there. Maybe Milo and Marianne will see it washed up somewhere. It wasn't my fault. I think the battery failed. So yeah, you always want a couple of drones. So it's pretty expensive upfront costs, but when you start to think about the pilot's time and the fuel costs, and it pays off pretty quickly. Does take a little bit more time to do drone surveys because you can get up in an airplane, you can cover a whole bunch of areas in one afternoon, whereas with drones you got to kind of go to one spot and then pack up and move over to the next spot and then survey that. You can't necessarily fly all of Glacier Bay in one to 3 days. But again, when you factor in the money, the cost savings of an operation, and the safety of just operating from boats instead of from airplanes, yeah, it makes sense. This is probably the main reason that we were using drones this summer with Prince William Sound Science Center. I could just say the Science Center. You're all there. You know what I'm talking about. It doesn't take a whole lot of infrastructure. You can just, this is pictures from my work when I was down in Antarctica. We would just pull up with a Zodiac. I'd hop out with a couple of Pelican cases. I think we just had one big Pelican case when we were doing the surveys in the Gulf of Alaska this summer. It's just extremely portable. You don't have to do a whole lot of planning and get the aircraft to your local airstrip. I know there's a lot of infrastructure for small planes in Alaska, but even still, it's a whole lot more work and planning than charging up your batteries and heading out with some Pelican cases. This is sometimes contentious, but I would say generally there's relatively low disturbance potential with drones. There are a lot of studies out there. In fact, this photo is from some work I did with my colleague Amy Bishop here in Anchorage. We were working out of Seward, looking at some islands in the Alaska Maritime Wildlife Refuge. And we were kind of testing how different drone models at different distances may or may not affect kittiwake colonies. And we had dedicated observers doing before, during, and after assessments of their behavior. And we did see, I did include that figure. We saw some slight changes. We saw, changes from resting to alert behavior, or I think, this is just saying that there were, sorry, I should have reviewed how I'm interpreting the figures. You can see the stars, so there's significant differences. Let's see. Some birds moved out of sight. I'm sorry, I'm doing a terrible job breaking down this figure, but basically we saw some minor behavioral differences. This is just me throwing up data. We have data. I'm not prepared to talk about it, but we have the data. We saw behavioral differences.
Look really cool.
Yeah, I know. They look really serious and scientific, and that's my goal. I'm a serious scientist. We saw behavioral differences, but also they were relatively minor. There were changes in behavioral state. This is also a kittiwake colony that had an eagle pretty regularly harassing it. Now, not when we were flying. We made sure we don't want the drone around when the eagle's around for the bird's sake or for our drone's sake. But I just kind of tried to take this all in the context of yes, drones can stress wildlife, but you have to take it in the context of what are the alternatives. If you want to get a complete colony count, would you be hiking on the island? Would you be bothering the animals? Would you be flying low in a helicopter, creating a lot more noise and disturbance? And then also, where does that disturbance sit relative to their, natural state? So if they're getting flushed regularly by an eagle, it's a relatively minor inconvenience that we're, changing some birds from resting to alert status. It's all, weighing the pros and cons. Is it worth it for the data to cause a little bit of disturbance? I'd say a lot of times, yes, assuming you're not doing it super regularly. But in general, compared to many other techniques, drones are a low disturbance method. And then, drones just give us, as I mentioned, that aerial photography aspect. You can get some really unique perspectives on wildlife that you wouldn't normally get to see. And here on the left is a photo from our work last summer. We had some caves and cliffs that it would have been difficult, if not impossible, very likely unsafe to get angles on these bird nests as we're trying to get the most complete count as possible for some of these kittiwake colonies. We were looking for a bunch of species, but we mostly found kittiwakes. And with a drone, you can just kind of, especially with a multi-rotor drone, you can get it hovering, you can kind of get the ideal perspective and get counts. And we were able to just get perspectives that'll give us a much more holistic picture of the colonies that we were surveying. And here on the right is a photo from some of the work I've been doing with, it's called the Juneau Whale Health Program. In Juneau, it's a team of whale scientists who are monitoring the whales that are most whale watched around Juneau. You guys are probably aware that we get a lot of whale watching tourism, and we have some whales that seem to tolerate it extremely well. But there's just kind of a question of, how well are they feeding? Are they stressed at all? How do they compare to less less observed, less, I don't want to say harassed, but less accompanied populations. And so we're using drones to get these great overhead shots, positioning over the whales when they're at the surface, getting some ideally a full outline of the whale's body, so then we can kind of track throughout the season how their body condition changes, how wide, how girthy they are at different times of the summer. And then, well, I'll talk about that a little bit more later too. So yeah, drones give us this ability to get very precise perspectives on the wildlife, whether we're talking about bird colonies or whales. And then, yeah, because you're flying drones generally way lower than you would be flying in a crewed aircraft, you can get some really nice high-res images. Ironically, these are all kind of blurry images, but yeah, the ones on the right were on a fixed wing that was moving pretty fast, so I think there's a little bit of motion blur there. And the one on the left, I think we were just flying at a high altitude. But these are all just generally examples, or I chose these examples because they show a couple of species that would have been really difficult to identify from a higher altitude in a more conventional aircraft. So on the left, we have some examples from seal surveys in the Pribilof Islands. After I stopped working there as a technician, actually my lab did a collaboration with NOAA to do drone surveys of Otter Island, which is one of the uninhabited islands in the Pribilofs. And I think it's super cool because it has 3 species of pinniped pinnipeds being, you know, seals and sea lions for you bird people. You guys know what pinnipeds are, you live in Cordova. It has harbor seals, northern fur seals, and stellar sea lions all hauling out in the same coastline. And so I thought that was just a great opportunity to compare the species in a few different ways. You can see that the harbor seals stand out pretty clearly. Some of them blend in with the rocks, but generally, you know, they're light seals in here, very dark volcanic rocks. Stellar sea lions also really pop in color, but those fur seals would have been really difficult to tease out among the mud and the rocks, especially with some of that dark volcanic rock that occurs in the Pribilofs. And so it really helped to have the resolution from drone imagery. And then here on the right is some work from my postdoc when I was at Wake Forest University. We were doing a bunch of work in the Peruvian Amazon, and one of the projects was trying to design these surveys to fly up and down rivers to see, just in general, how reliably we could detect different species of wildlife. And these are some caimans. I'm not 100% sure that blue box is a caiman. I think it is, but that red box is definitely a caiman. And yeah, you can just so like you wouldn't be able to, if you saw them at all, you wouldn't know that they weren't driftwood from a higher altitude. So it was just to me another great example of wildlife that you wouldn't even be able to detect if you didn't have that low altitude camera that you're getting from a drone. And then I'll kind of elaborate on this a little bit more, but when we're flying drones, a lot of times we're getting a huge density of data, partly because drones are flying more slowly than occupied aircrafts because they're lighter, they can go at slower altitudes, and slower velocities. And because you don't have a human in there, you don't have to worry as much about that safety margin of moving fast. So a lot of times when we're flying, you can do really tight flight plans and just kind of saturate an area with photography. So this is a flight plan from a couple islands where seals haul out in Glacier Bay. And the back and forth, that red line was the flight path of the drone. So we'd call that like mowing the lawn. Basically, you're getting kind of contiguous transects that are overlapping and parallel wise. And then you can kind of make out that these are rectangles representing, oh, I hit a button. Okay, here we are. So those kind of that gray film over it is just a ton of rectangles representing the footprints of our photos. So we're just getting a ton of overlapping photographs that we are then able to stitch together into this, what we call a photo mosaic or an ortho mosaic because it's orthorectified. I'm not going to get into that, but it's a mosaic. It's kind of like when you stitch together a panorama, except it's super precise because you're getting coverage from all these different angles. The reason why the mosaic is a lot smaller than the survey area is because there's a whole bunch of water and you can't really stitch water because it's all moving. But you get these really beautiful high resolution maps, and even some structure like elevation maps, and I'll show some of those later. And that's just because, like I said, you're saturating a lot of times when you're doing drone work. You can collect a huge amount of photography or video or whatever you're looking for. And on top of that, you're also getting a whole bunch of data on the drone's flight log. So you know the position of the drone. A lot of times you know the angle of the camera. You are getting whatever data the drone is assimilating. The wind that it's the wind pressure that it's receiving. Just a huge amount of data from a single flight, and that just opens up a lot of doors for how we analyze data. Oh, I need to reactivate the light here. I don't know if I've ever stayed in the office this late.
You're locked in.
Yeah, I have a night at the museum experience, except a lot less exciting at the state office. I could do the flashlight. I could do the scary stories. Let's see.
You're good. We can see you.
All right. Well, we're going black and white here. Thanks for bearing with me. So yeah, a lot of density from these data. Some of the limitations though that we encounter when we're using drones. I'm gonna keep the strengths here in the corner so you don't forget about why drones are great while I tell you why drones are difficult. Battery life. Limited battery life and limited range that you can fly. So like I mentioned, we can cover a whole lot more area in a Twin Otter or one of these small aircrafts. You guys know all the names better than I do. So on the left here is an example of when we were doing the SEAL surveys at Johns Hopkins Glacier with an occupied aircraft, pilot and people on board. And then on the right is some examples from when we switched over to doing drones. And as I mentioned, because the drones are flying slower, we have a lot more continuous coverage. Each of these colors, the red, yellow, and green, are flights. So this was 3 flights to cover the area where there was floating ice that the SEALs were hauling out. Conveniently, there's less of that now than there used to be, so we could cover the whole field of sea ice with just those 3 flights. But in one afternoon, way less than one afternoon, they were able to cover that whole area, the whole length of that arm of the inlet with an occupied aircraft. And then on top of that, we have the limitations that, at least for a long time, we haven't been able to fly beyond the line of sight of the pilot. So there's just kind of a hard limit on how far you can fly your drone. They're working on that. I'll talk about that a little bit more with regulations, but yeah, in general, drones are great if you have a concentrated area like a bird colony or seals that all hull out near a glacier or on an island. But like, for example, in Glacier Bay, they're not going to switch over to drones for sea otters for a long time. Well, you guys know, you guys have sea otters. They're everywhere. They're floating around here and there. And it's not, sometimes you get a high density, but when you need to cover a large area, it's going to be a long time before you can do that with a drone, given current battery life, 20 to 40 minutes with a copter, maybe 90 minutes with a fixed wing. Drones also have a kind of a limited weight that they can carry. So here are a few of the more advanced sensors beyond just your color camera. We have thermal sensors, multispectral sensors for looking at vegetation dynamics. When you get into the infrared spectrum, you can get some cool stuff there. LiDAR, so that's using lasers to scan things in 3 dimensions. Hyperspectral, and you're looking at a lot of different sections of the light spectrum beyond visible. I didn't have a great intuitive grasp of what 4 kilograms is. I work in science, I work in metric, and then in my day-to-day life, I work in imperial. So I looked up, 4 kilograms is about the size of a healthy cat. So that gives you an idea of what the upper end of what a drone could carry. I do not recommend carrying cats with drones, but it could handle it. Yeah, it's getting better as the drones, the efficiency of the drones is improving from batteries and just the general design, and also the payloads are getting smaller as they get more refined. But just for comparison, here's a state-of-the-art LiDAR hyperspectral setup for, I think this is Arizona State University now. It was at Stanford for a while, but they operate this and they do these incredible scans of a lot of times, rainforest habitat and structure. And yeah, it's just, you need a much larger aircraft if you're going to be using that kind of high quality calibrated payload. But for the right projects, if you accept the limitations of your data, you can put on a couple of these sensors onto your drone. Platform dependability has been an issue for a long time. It's getting better, but certainly in my time using drones, actually, this is a DJI drone in this picture, which I totally just found on the internet. And I found them to be extremely reliable, but a lot of the American manufactured drones, they don't often arrive in a ready to go condition. And I'd say this for some of the Chinese drones I've used too, that weren't DJI. You'll buy them and they kind of expect you to troubleshoot with them, which is fine if you're in North Carolina. But when I was in Antarctica or in the Peruvian Amazon, you can't just get a new inertial motion unit. It's been a challenge. Buying drones, relatively expensive drones, and then finding that they just weren't really built at a reliable quality. Also, a lot of times the problem is on the user side. If you know somebody who flies drones, you probably know someone who's broken a drone. And yeah, in this particular picture, the guy's not even plugged into a screen, so he's flying blind, and that's clearly why he broke his drone. But I am generally seeing that drones are getting better, especially as Chinese drones are getting phased out. I think some American manufacturers are starting to step up and produce more reliable products. I'll talk about that in this one. Okay, yes, regulations have been a big challenge for flying drones. I mentioned, there's a line of sight issue. For a long time, we weren't allowed to fly, I think within an hour of sunset. Now you can fly after dark with the appropriate lighting, and I think you need a strobe on that can be seen by for a certain distance. They're working on the beyond visual line of sight laws that was supposed to happen last year and probably won't happen until next year, but they're working on it. The FAA is making progress and kind of taking away the red tape for using drones. But then, Congress is adding more red tape, banning us from using Chinese drones, which I'm not going to get on that soapbox, but it's going to hold us back. And then, there's also a lot of hostility. Do I hear a question or people just laughing at the guy threatening to shoot a drone here? That's happened to me, actually. I was working in Montana doing... Oh, did I hear a question?
Oh, no, he just said he's shooting the guy, and that's because it's invading his privacy.
So that's a challenge. Sometimes people rightly are upset at drones that are invading their privacy, and sometimes they have an expectation of privacy when it's not necessarily even their land. So in my case, I was working over state land in Montana, surveying an area for archaeological signs, and the owner of, I'm not even sure he was the owner, he might have been a renter of an adjacent lot, came out, drove out in his big pickup to tell me that if he saw my drone again, he was going to shoot it. Now, good luck shooting a moving target in the sky. I don't know how good he is, but it was, I apologized for the perceived intrusion, explained what we were doing. I think he eventually got the memo that we were just a bunch of nerds who were excited about, mapping archaeological signs in state lands. But there's generally a feeling of violation that people experience when they encounter drones in places that they wouldn't normally. And it's, some of it's deserved. There are certainly a lot of irresponsible hobbyists out there. And, I try to, wear a nice high vis vest and look official when I'm out flying if I do expect to encounter people. But it's something that we good pilots struggle with because there are a lot of bad pilots out there. So having gone over the pros and cons, and again, I'll leave the pros up here and I'll let you guys forget the cons. Here are some of the ways that I see drones really opening up new doors for wildlife. This is, again, going back to the work that I've done with the Science Center, just getting a more complete picture of habitats that you wouldn't be able to see necessarily, in this case, from a boat at sea level, or when I was working the Pribilofts, sitting in a blind on a cliff. You can see a lot, but we were always losing seals under the cliffs, in little caves among the rocks. When you've got complex terrain, it's really just invaluable to get that overhead perspective. That's kind of the most obvious way that drones can help wildlife work. But then, as I mentioned, when you start to get a ton of that imagery, you can put it all together into a much bigger picture, because you also have all the GPS information from the drone. You can start to situate those animals in space. So this is going back to that survey in the Pribilofts, looking at the 3 species of pinniped that were on the north coast of Otter Island. We were able to get the counts that's what NOAA was looking for, but more than that, we got the locations of the animals, so we could start to see what kind of terrain the animals were navigating. And it's a bit of a no-brainer. I mean, harbor seals are not going to be like pioneering up the mountain inland, but it was cool to see that the fur seals they were moving in towards this little cinder cone. We only had 17 stellar sea lions, and they all stuck together, so we couldn't really make a lot of inferences about how they use habitat. But I just thought it was a great opportunity to kind of see and contrast how the different pinniped species use habitat, even in the same place. And then, just to expand on that study a little bit more, here on the left is we didn't just do that in color, we did it in color and thermal imagery, and it was a pretty cool study design. We were using fixed wing planes, those little black drones like I showed you in the beginning of the talk, and the thermal camera is a lot lower resolution, so we flew the thermal at like I think 55 or 60 meter altitude, and then the color at 120, and did the flight plans at the same time. So they had 2 drones in the air at the same time. Some of the photos even have one drone looking at the other drone, but because of that, we got synchronous imagery. So the animals were in the same place. Even these, I can tell you the fur seals especially are extremely squirmy, but because we got imagery of them at the same time, we were able to sync up the mosaics, and it made it much easier to get a count. Again, looking at that, well, you can see in the imagery, just the fur seals pop a lot more in thermal than they did in color, and it really helped with all of the counts. Just kind of confirming, like, is that a piece of driftwood or is that a stellar sea lion? It wasn't really a question in this case, but there are a lot of times that you're not really sure. The animals, they've evolved to camouflage with the landscape, so the thermal was a really nice benefit, and that was able to stitch together as well. And then I think I mentioned this earlier, but when you're getting all those photos from different perspectives, you can also generate 3-dimensional products. Or here we call this a 2.5 dimensional because it's a 2D representation of the 3rd dimension in the pixel values. We're getting the elevation map of the habitat, which of course I was excited about because as I said, I was kind of interested in the topography, like how far does a fur seal go up a hill before it decides like this is good enough and I'm just going to nap here. So yeah, if you guys want to know more about that, I could talk about that later. But yeah, basically, if you think about taking photos of an object from different perspectives, you can kind of recreate the 3D structure of that object, and that's what we're doing with the land that we're surveying. So, and people do entire projects just on using drones and this technique to like measure how much gravel is being taken out of a pit. We were talking about that today in my state job. This is much more exciting in my opinion, looking at the 3D habitat that wildlife are using. Need to make sure that I think the office is empty. The lights are off. Nobody's hearing me talk about material sales. I call this ad hoc deployments. Just basically with drones, you can take advantage of really unpredictable moments or moments that are hard to predict. So like, when we're working with whales in Juneau, well, this photo's from Antarctica, but same situation. You're working with whales, that they're out there generally, that they're feeding at this time of year in this area, but you don't know when and where they'll be at the surface, and you can get that great shot of their body. But when you're out in a boat and it only takes you like 5 minutes to launch a drone, and you come across a whale that's, doing pretty predictable behavior, you can, keep your batteries charged until you've got the right whale in the right time, and then get that drone up in the air in like 3 to 5 minutes and start collecting these body images, or these, if you want to do behavioral video, you can just take advantage of the fact that there's a really quick deployment time. And this was something my lab did a lot in North Carolina, because we were in hurricane country. Suddenly a hurricane is bearing down on coastal North Carolina, and everyone else would be packing up and making emergency preparations. And our lab would be like, let's get the pre-storm survey. And they'd go out and do these mapping surveys of the barrier islands so they could see how the geomorphology changed before and after the hurricane. And it's just one of those things, like, you wouldn't be able to really plan that with, it'd be difficult to plan that with a conventional aircraft and pilot. Not a lot of pilots want to be, bringing their aircraft towards the hurricane. But yeah, when you've got a drone, it's just that much easier to take advantage of the opportunity when it arises. Oh yeah, so this is just a quick explanation of kind of what it looks like when we're doing an analysis of the whale. This is a PowerPoint markup, but you could imagine a much more scientific program doing this. You can measure the length of the whale with a drone. You know about how high you are over the whale. Generally, we know that just from either the GPS reading or the barometer on the drone that tells you about how high you are based on air pressure. When we're getting really serious about making measurements on whales, we usually put a laser on it, just a laser rangefinder that'll tell you within a centimeter how far you are above the water surface. And once you know how high you are, you know the how many pixels are in your photograph, you know the width of your camera sensor. You can do all this trigonometry. Think way back to sophomore year of high school, probably. You're doing your like angles and the hypotenuse of the triangle, but you can calculate how big each pixel is that representing on the water surface. And so then you can measure pretty precisely the length of the whale. And then that's where we start to get the measurements of how girthy the whale is, what's its body condition like. And I think I included, I'll talk about that a little bit more down the line. This is just the other thing that we do with whales. I've been starting with the whale team in Juneau is blow sampling. And again, it's one of these things where you're waiting for the right whale that's cooperating. Wait for the whale to get to the surface, fly your drone through the blow. We strap a couple Petri dishes, we Velcro on a couple Petri dishes. But you want a whale that, you can predict where it's going to be. That blow usually dissipates within probably 5 to 10 seconds because there's usually wind on the water. You want a whale that's not necessarily in a group, because then all the blows are getting mixed. And you don't know whose blow goes with which whale. We're interested in getting hormones out of that, which, there are hormones in the blow from the mucus that the whale's producing. So this is just another example of, waiting for the right opportunity and taking advantage of that. Okay, here's where I'm going to talk more about the photogrammetry. And it's in the context of doing repeat surveys. So because drones are cheap and relatively easy, once you've got the equipment, you can get out and use it, with very little overhead costs. You can start to look at seasonal processes. So like I said, measuring the whales go throughout the season. In a place like Juneau, we have the same whales for a few months in the summer, and you can start to kind of look at how their body changes. I think this paper that I'm showing here from my colleague, Casey Bierlich, this was from Antarctica, and we didn't actually know the whales. We didn't have as reliable a population. I think that this is just kind of a group of whales measured at different times in the season, but still you're able to get a general trajectory of how body condition changes throughout the season. And this was kind of an interesting question because down there, it's warming. We know a lot of polar areas are warming. There's the feeding season for humpback whales is getting longer because they're generally kind of pushed out as the ice sets in. The season during which there's ice in their feeding areas is getting a lot shorter, so they're able to stay longer. We're seeing them stay longer. And so there's kind of this question of like, if they stay longer, how's their body condition going to change? Like, is it going to be a linear thing? Like, they're just getting, 5 more days of the same, or something that people have seen a lot of down there is there are kind of these feeding frenzies as the krill get packed into these bays. And there's a question of like, are they packing on most of their weight in the last little bit of summer? And so if that last bit gets extended, will it be, even more weight, or will we see different dynamics? And basically what we're seeing is there's kind of a linear process, like taking it with a grain of salt. This supports the hypothesis that it's a relatively linear process, that the whales are kind of building their mass throughout the summer at a pretty steady pace. And just that's all in the context of these populations. I'm sure you guys know about humpback whales and their migrations. They arrive, some of these females have been nursing a calf the whole way, and they've migrated across, an entire hemisphere. And so they arrive relatively emaciated, and they need that period of time to pack on their mass before they make the migration back to their breeding grounds. So this is all kind of the context for what we're doing in Juneau, exploring that period of body mass recovery. And then this is just a little bit of an overview from a chapter of my dissertation where I was really excited to explore the seal counts, I guess, throughout the season. I won't jump into that just yet. I was down at Palmer Station. I was working with the Palmer Long-Term Ecological Research Program, and this is a NSF-funded program that looks at a bunch of different aspects of the ecosystem on the Antarctic Peninsula. So again, this is right around where Milo and Marianne are headed right now. But for a number of reasons, including the fact that fur seals weren't really seen near Palmer Station until the 60s, there's not a whole lot of research that's gone on studying fur seals. And so I was interested in getting an idea of just how many there are there down there. And even to get that very basic number, you have to have an idea of when are the seals there. And so while I was down at Palmer, I was started doing surveys of these areas that we saw seals. Every 7 to 10 days, I'd try to get a flight over so we could get counts. And so here again, these red blotches are my flight plans, or the flight routes. So that's where I flew the drone. I don't know if you can see that. You can kind of get an idea of where Palmer is because a lot of the flights take place around Palmer Station there, on that little peninsula off of Andrews Island. But throughout the season, I just got a whole bunch of seal surveys. And here's a picture of what those surveys look like. You can see some elephant seals here in a wallow, I think they're molting and they're just kind of being gross, laying their dead skin and other byproducts. And the fur seals are scattered throughout the landscape. I'll give you a second to kind of look around and see how many fur seals you can spot. This is just to give you an idea of the the painstaking process of seal counting. So here are the seals. The elephant seals are in green. The fur seals are in red. And again, it just kind of underscores why it's so important for us to have this high resolution imagery, because otherwise those seals would blend right in with the rocks. And so then, scaling this up to island-wide surveys, here's a couple surveys at different dates from Torgerson Island, which is one of the more commonly visited islands near Palmer Station. Here's what that looks like in the context of all the surveys I did of Torgerson. So we had like one little seal around January 15th, but then, we get this pretty steady climb towards early March. And then here are all the surveys that I was able to do for about a dozen different sites. And what I was really excited about here, just plotting out the counts, was that you can kind of see a common trend across a lot of the sites with this interesting little pulse in February, and I've got some theories about what that might be. But then, the peak was in early to mid-March. And so that gives us an idea, like if you wanted to see how many seals are visiting Palmer, you kind of want to target this early to mid-March area where you have the most seals. And because we're able to see this trend across multiple sites, you might even be able to get away with just monitoring a couple key index sites, maybe even just put out some game cameras and watch some key haul outs. So I just thought this was a great opportunity, a great example of using drones, taking advantage of how easy it was for me to fly drones. I was doing this in my spare time when I wasn't collecting whale data to get an idea of the seasonal process of when fur seals are near Palmer Station. Also, as I was working through all these seal surveys, I noticed that we were able to also monitor giant petrel nests. So I noticed, these funny little mounds of shells. And then I noticed, the little puffballs that turn into little gray footballs throughout the season. So just from these, near weekly surveys, we could keep track of these giant petrels. If you're not familiar with them, well, you know what petrels are. They're large predatory birds. They tend to nest near penguin colonies where they will often scavenge on the chicks that don't make it. They also, we think, kind of place their nests near katabatic winds that will help them take off, particularly when the chicks are fledging. They need a little bit of extra lift because they're pretty large birds. And so, yeah, we were able to watch as the successful nests, the chicks matured. We were also able to identify unsuccessful nests, whether they were fakers who looked like they were nesting and then never actually laid an egg, or sometimes we saw chicks that then disappeared, and that could be a confirmed failure. So that was a nice example of using drones to non-invasively monitor these bird nests. And then also we were able to look at a little bit of the topography of where they chose to nest. This is getting into the big and controversial topic of AI, but because we have that awesome high resolution imagery, you can train models to help kind of speed up the data analysis process. So if you think about that spot the seal slide that I had earlier, you can pretty effectively train a model to detect seals. It's not going to be perfect, but in my opinion, it can help speed up the process. So this was some work that I did. This was 4 years ago now. I wasn't using any of these fancy Google or Microsoft models. This was all on a Linux machine with some Python code. But yeah, I got to train up a bunch of models on some gray seal surveys from the Northwest Atlantic, some from NOAA, some from Department of Fisheries, Oceans Canada. And I was also interested in seeing if we could tease apart pups and adults. And we had moderate success. One of the more useful things I got out of it was kind of seeing where AI breaks down, but also where AI shines. So here on the top, we've got some examples of things that the AI thought were seals, but were not, like rocks here and snow patches that it thought looked like pups. This bird doesn't look anything like a pup, but for some reason got classified that. Here's a false negative. So this was a pup that it lost here in the purple, kind of blended in with the snow, but also the AI was able to find things that I missed, spotting some pups and even some adult seals that I'm a little embarrassed that I didn't recognize them, but hey, maybe that adult looks like a log, I don't know what I was thinking. I was looking at a lot of images, so I'm not surprised I missed some. So yeah, my general approach to AI is I would not put AI in the driver's seat, but I'm happy to have it in the passenger seat helping me along. I think it can really speed up that bottleneck of, when you've got a ton of data and you need to analyze it. But I don't think anybody should trust it, without human review, because we just don't know what the error rates are. I'm going to just gloss over this really quickly. We have a colleague who's exploring kind of how AI works. So it's less of a black box, kind of putting seal images into algorithms and seeing kind of what gets activated, what's the AI honing in on, and that might kind of help us explain. I think I'm going a little over time, so I'm just going to skim that. But explainable AI is a cool new frontier. That's a takeaway. And then this is a colleague of mine used AI to classify whales and whale imagery. I think it's kind of an easy task. You got a whale and then it's water. It's not like, seals on snow, but anyway. Yeah, so this is kind of the summary. It's all things I've kind of talked about so far. So I'm not going to spend too much time on this because I want to talk about the work that I did with the Science Center. So this is the beautiful research vessel, New Wave. There's me in the middle sitting down with my thin hair, and there's Marianne with her little blue helmet getting ready to catch my drone. We did surveys this year in Hinchinbrook, in the Martin Islands there over by Katala, and Wingham Island. And these are all sites that haven't been officially surveyed in decades, and so it was really exciting. A little bit sad to get it out there and kind of see how the colonies are doing. They're all way down from the 70s, but that's I guess to be expected, sadly. Here's just some footage of what they look like. The photography would be a little bit clearer than the video, and I'm sorry that the drone is kind of wobbling here in the wind, but yeah, just some spectacular field sites. Also, you can imagine, just how hard it is to get a count of some of these bird nests as they kind of go over the cliff. We were doing surveys from the boat with, I'm very sorry, I forgot her name, but we had a fantastic colleague who was really good with a camera and had a zoom lens and was taking photos kind of sidelong from the boat. And I would say that, she was getting, the best possible quality of those side facing nests. But then, yeah, again, she was kind of limited as to how high up the cliff she could look. And so then we were kind of doing a complementary survey. And this is one of my big takeaways from working with drones. Like, drones are not going to put people out of work, but they complement a lot of the conventional techniques. So, yeah, I'm kind of curious to check in with Marianne. I haven't been a part of the data analysis, but I think we're going to get some really great, robust counts of these colonies. So yes, the goal of our project was to try to get the most complete count that we could. We use Zoom for, oh, this is all the stuff I just told you. I forgot that I had a slide that basically summarized that. Yeah, Zoom photography from boat, aerial from the drone. Results, generally successful, no safety concerns. Always really nice when you're flying a drone into somebody's hands on a moving boat when nothing goes wrong. And we practiced on land over at the ball field before we got out there. The drone didn't fall out of the sky. That's always good news. I would say I have some room for improvement on the technique. I would say where the places where I saw that our data has been coming up short is mostly my limited abilities as a photographer, dealing with the autofocus and the exposure. There's a lot of photographic skill that comes into this kind of work with wildlife, and I am still very much in the learning stages of that. So yeah, discovered that autofocus takes a little while. I had the camera on a 2-second timer, and I think the autofocus takes maybe 3 or 4 seconds. So we got a lot of out-of-focus imagery on some of my flights. I think we kind of figured it out partway through the surveys. So none of our sites got totally skunked with fuzzy images, but there are a lot. Lighting is a challenge. I think I would recommend in the future that we do multiple flights, one at low exposure, one at high exposure, depending on the time of day and the species that we're looking at. So in this example, I mean, you can see counting kittiwakes in the shade is great with this exposure, but once you kind of cross that line and you're in full sun exposure, it gets a lot harder to count. And we can address that by turning down the exposure. But then on the other hand, if a lot of these sites, we're also looking at cormorants, and you turn down the exposure and a cormorant is going to blend right into a crack in the wall in the cliff face. And so depending on the species, depending on the lighting that you're dealing with, how direct the sunlight is, or if it's overcast, you're just going to probably need a couple passes with different exposure settings. Again, that's just me kind of getting better as a photographer. And then, yeah, we were pretty conservative this year, not really sure how the colonies would respond to the drones. It can vary by species. It can vary by where they are in their nesting cycle. If some birds are more flighty when they have a nest, some birds are more stubborn that they're going to stay with their egg. So it's really kind of context specific. What will disturb the birds and to what degree. We found that there were really no observable disturbances from our flights this year. I think that we could probably get a bit closer and get just clearer images, better counts, while keeping an observer kind of focused on the birds to make sure that we aren't causing stress to the colony. I think that that's an area that's still ripe for exploration as we kind of refine our technique. And I think that was it. Yep. So I'll just leave it with this beautiful video from Boswell Bay, your local kittiwake colony, where I practiced drone work with Marianne the first day that we got out in the water. Thanks for bearing with me, and yeah, in the dark here. I can't hear anything. I don't know if that's a me problem. Oh, I can hear things now.
Greg, it's Katrina Hoffman. Can you hear me okay?
Yeah, hi, Katrina.
Hi, nice to see you. Thanks for that presentation. It's good to hear more about your work. You mentioned that you in Montana had done some work on an archaeology site. And
Yeah.
I'm thinking about a recent archaeology disaster in Winahawk at the Nunalik site. The typhoon really ravaged one of those archaeological sites. And this week, there are people going out there and trying to identify and recover Yupik objects that are hundreds of years old before the ice scours are destroying them. Are you aware of whether the state of Alaska is going to deploy any drone resources towards that effort? Or have you talked to anyone like Nora Numinsky about it? I'm just curious if skills like yours could assist with this recovery effort.
Yeah, I can tell you that there is a state drone pilot out there. A friend of mine, Brian Payton, is out there with DOT. But I think he's focused on roads and materials. Yeah, I might, see if I can find the OHA. I can't. The office. I'm still learning all the acronyms here in the state government. But yeah, that's a good question. I'm not aware of, certainly not drone specific. I'm kind of curious what the state is mustering for kind of cultural and archaeological values. I hope so, but I would be surprised if they have a drone pilot out there specifically for that. But that's a great conversation for me to start.
You might want to contact Christy Mogg, our archaeologist here with the Forest Service, because we do have a federal group of drone folks that I think she's been working with, and she might be able to give you some leads. And Greg, did I hear you allude earlier in the talk that Eagles will take out drones? I've heard that. Is that like something they do often?
I don't know if there's enough sample size to really make to tell a trend or not. I have definitely heard stories of eagles attacking drones. I can say our lab's experience when we were in Antarctica, a skua attacked a fixed wing, one of those black styrofoam planes, and took a chunk out of its wing. Still flew fine, but I think fixed wings tend to elicit more of a territorial response because they look like birds. I think they can also, depending on the species, elicit more of a flush response. Copters, I mean, I've seen, I think, a couple of YouTube videos of copters getting taken out. And even then, there's a question of like, how much of it is aggression versus curiosity. I had a friend who was flying in Peru and definitely got buzzed by, I don't know if it's a falcon or a hawk or some bird of prey buzzed him. But that was a curiosity thing, I think. Like I said, I'm not sure that there's enough of a sample size. I don't think we want to get to a good sample size where we can tell a trend. But in general, it's one of those things like, if you see an eagle, maybe don't launch your drone. In fact, definitely don't. And like I said, it's bad. The birds are stressed if there's an eagle around, so you just don't want to compound that bad situation.
Thank you, Greg. We certainly appreciate your expertise tonight. And people might have been hearing my phone ding. Marianne is texting me right now. She just went to bed, but she says they just saw steamer ducks today. And she wanted to thank you for coming to our first talk of the season.
Oh, I didn't know it was the first. Oh,
yeah.
Well, I hope that the rest of yours are a little brighter than this.
Thank you again.
Well,
night,
and yeah, if
Greg.
anybody has questions, feel free to email me. Thanks, guys.
Thank you.
Bye-bye.